next we will be looking for the copying algorithm in single linked list. So before going to the algorithm, I would like to explain with the help of an example. So what do you mean by copying? You already have an existing linked list and you will be copying the same linked list to another linked list. That is, you are making a duplicate copy of the present existing linked list. So what should we do this? Here we have example of a header node, 10, 20, 30, 40 are 4 numbers and we have 4 nodes. So we will begin from first we should copy, we should use mainly the algorithm of get node, and then we should copy each of the content to the newly made new nodes, right? So first let's take the duplicate header node as header 1. And definitely we have to make it as null part of the data type, and we will start with a link. So referring to the algorithm, here we are starting from header link. Header link means the header link portion of the header node contains the address of the first node, right? So and that is given to the variable ptr. So naturally ptr will be pointing to the first node. Now we will go for the next line. Header 1 is equal to get node of node. That means with the get node algorithm we are using new node, and that will be given the name of header 1, and that is what we have done here. I have brought a new node with the help of get node algorithm, and then header 1 is the name given to it. Now what is happening here? Now ptr1, another variable, is also assigned the value of header 1. That means here now this will be known as ptr1. That is, the duplicate first node which I have created now will be referred to as ptr1. Now what is it? Ptr data is null. That means the data part of ptr is null. Now we are going for a looping structure in while loop, and this while loop goes until the ptr becomes null. Okay, now again next algorithm is new. And what is new node? Get node algorithm. So we create a node here, let it be new, and I have created this node using the get node algorithm. Now what happens? New data, that is the data part of new has the data part of ptr. New data is equal to ptr of data. That means the data part of new will contain the data part of ptr. Now what is ptr? The first node of the existing linked list. So this data is 10 and I am giving it here. Now ptr1 of link is equal to new. Ptr1 of link is equal to new means this ptr1 is already the header 1 and the link part will contain new. That means here this pointing is realized. Now new link is null. Presently I keep this portion as null. ptr1 is equal to new. ptr1 equal to new means now first before I was pointing to this node, ptr1 was pointing to this node. At the end of this looping statement I will be giving this as ptr1. That means now ptr1 will be pointing to the new node, that is a first node in our first running of the loop. Now we have also to increment the before existing linked list, and that is done by with the help of the statement ptr equal to ptr of link. So ptr equal to ptr of link means now ptr will be pointing to the second node, right? So end while means we will be again repeating it. Now is ptr equal to null? No. So naturally we will be creating the second node. Now we will go again. I have created a new node using the get node algorithm, and the data part of new node will contain ptr of data. ptr of data means it is the second node and it is 20. ptr1 of link equal to new. ptr1 of link equal to new means now ptr1 is pointing to the first node of the duplicate list, and that link part will hold the address of the new. New means the second node. So what happens? Before it was null, and that will be overridden with the address of the new node. So now new link is equal to null. That is, the link part of the newly created node is null and ptr1 equal to new. So in the second running, this statement means now ptr1 is pointing to the second node. ptr equal to ptr of link. Naturally, ptr will be pointing to the third existing node. And this continues until we create all the nodes. See, so therefore this loop will be running 4 times since we have 4 nodes. And when will this loop stop? When it reaches here, naturally ptr will be pointing to this, and after that increment ptr will be pointing to the null part, right? ptr equal to ptr of link means ptr of link is null, and when it goes we will be exiting here, and naturally the while loop will be running 4 times in our given example. So what we have done is we have already creating a there will be an existing linked list, or we will create a linked list, and then in copying algorithm what happens is we are creating a duplicate of the existing linked list. Okay, next we are looking for searching algorithm in single linked list. So what is searching? You have already an existing linked list and you are searching in that linked list for a particular data. The data may exist or may not exist. So if it exists, you get return as the data and its position, and if it does not exist, you get a message the search is unsuccessful. So naturally for searching algorithm you have to start from the beginning of the header, beginning of the linked list, and then naturally you will be starting from the header and you have to traverse through the linked list. While traversing, at the same time you have to look for the data part and whether it matches the key value. Key is the data which we are giving that has to be searched. So let's take an example. Let key be 30. Okay, so what happens here? The key is 30. So naturally I'll be starting from the header node. I will look for the I will traverse through each of the node, and at the same time I will be looking for the data part, whether the data is, of the linked list or the node is equal to the key, and it will go. So this has to be in a loop. Then what happens? If you find the particular data that is equivalent to the key value, you have to give a message that the search is successful, provided you also have to give the location of the particular key value. If it does not exist, naturally you will giving a message that the search is unsuccessful. So let's go for the algorithm. Naturally ptr equal to header, that's you have to start from the header node. ptr will be starting from the header node. ptr header link is given the value of ptr, that is now ptr will be starting from the first node. Now here we use a variable flag. Flag is a variable, something like a kind of register value or just a boolean value. Flag equal to 0. Initially flag is set as 0, and this value is changed if you find the particular location or the key value data is available in the linked list. Now location is also set to null. Location is a point, that is the address where the particular node exists. So presently it is initialized to the value null. Now we go for the loop. While ptr is not equal to null, and when also flag also should be equal to 0. So here we have to have 2 conditions. You go until you have either of the condition is broken. So naturally we will be using for a AND operator. What are the 2 conditions? The ptr should not be equal to null and the flag should be equal to 0. If either of the value is false, the while loop stops. So that is a operation of AND. And next what happens, then you have an if condition. In the if condition you specify whether the data of the particular node, data part of the particular node is equal to the key or not, and if it is, you have to do some set of statements, else naturally we have to go for the next node. So what happens if the data part is equal to the key value? Naturally you have to reset the value of the flag variable, you have to return the location, and also print the search is successful. So first we will be resetting the value of flag variable, and that flag variable will be set to 1. Then you have to give a value for the location variable. Naturally we will be having that in the variable ptr, and ptr variable address variable is given to the location variable. Next you give the print message and you return the location. So you will be giving returning the address of the present key data. If suppose we did not find in that particular node, then what happens? You go to the next node. So in this case, in our example, I have given the key value as 30. Naturally we will be looking for the first node, since if condition is not valued here, right? ptr of data is not equal to key. So naturally we will go for the else part. What happens? ptr equal to ptr of link. That means ptr will be pointing to the second node. Again we check for the data part whether it is equal to key or not. Naturally here also it does the if statements need not work, and naturally we will go for ptr equal to ptr of link. Now ptr will be pointing to here, third node. In this case we find is equal, that is ptr of data 30 is equal to the key value 30. So what happens here? Naturally we have to reset the value of the flag. Flag becomes 1. Location is found from the ptr value, that is we will get it as a third node or whatever is printed, maybe the address of the particular node, and we give a message search is successful, and also we return the location address of the node. Now since we have reached the value, what happens here? Here note this, the flag value has been reset. Naturally after this, if statements are executed, we will again go for the loop. But what happens here? Since we are using an AND operator, as I said before, here this condition becomes false, right? This flag equal to 0, now it has become flag equal to 1, but this condition has not become false, it is now also true. So but since the flag condition has become false, naturally the while loop will exit and it will go to this part. Now next part is we will look for the if condition. It's an if statement, ptr equal to null. Our ptr is not equal to null, so we can ignore this statement. Okay. Now what happens? So as a result we get two things. We will get the value of location and also message, not message, search successful message, right? These are the two things that we get as a result of the search successful. Now suppose the search is not successful, what happens? That is, search is not successful means I am giving some other key value. It would be 50, right? As you can see, 50 is not in this linked list, so computer cannot see, it has to go until the end. So as I said before, naturally we will be going for the while loop, and it will be incrementing one or traversing each and every node. So in this example, since the key value is 50, it will be reaching till the end, right? It will also go to the last node. So if statements need not be executed in this situation, naturally what happens here? The flag is equal to 0 after the 4 times execution of the loop, and during the 5th time it will this while loop will be exited due to this condition, right? ptr becomes null when it reaches to the 4th node. In the 5th time when it is going to being executed, ptr becomes null. Naturally it will exit out of the while loop, and what happens here? Now ptr, this while loop has exited due to this condition ptr equal to null. Naturally we have the next if statement to be executed, and at this time this portion will be executed. That is, when ptr is equal to null, we have to give a message that the search has been unsuccessful. Because what do you mean by saying ptr equal to null? Ptr equal to null means we have reached end of the linked list, and that means we have not found the key value. So naturally we will get a message that search is unsuccessful and we have to end the algorithm.